All right, let's get right into it. The entire world of AI is pretty much built on one simple idea. The more high-quality data you feed a model, the smarter it gets. But what happens when we start to, well, run out of that data? Today, we're going to break down a massive experiment that tackles this exact problem. And it's all about turning the messy art of data creation into a real science.
And when I say massive, I am not kidding. The researchers we're talking about generated over 1 trillion tokens of new data. Now, just to put that in perspective, a token is basically a piece of a word. So a trillion of them, that's like processing millions and millions of books. It is an absolutely staggering amount of information, all created in the hunt for the perfect AI training recipe.
So our guide for all this is the Synthetic Data Playbook, a paper from a brilliant team at Hugging Face. Get this. They ran 90 separate experiments and dedicated over 12 GPU years to this project. That means it would take a single, really powerful computer 12 years of nonstop work to do what they did. It's just a huge investment to answer one of the biggest questions facing AI right now.
You know, it all boils down to this fundamental principle. For years, the path to building better AI was simple, right? Just scale up. Feed the models more and more text from the internet.
The problem is, we're hitting a wall, a data wall. We've pretty much scraped, filtered, and used most of the good stuff out there. The well is seriously starting to run dry, and it's created a kind of data crisis for the entire field.
And this leads to a really fascinating idea. If we can't find more high-quality data, what if we use the AI itself to make it? This is the whole world of synthetic data, and it might just be the key to unlocking that next big leap in AI performance.
Okay, so to really get why synthetic data is such a potential game changer, we need to take a quick look back at how we got here. See, this isn't just some new, flashy technique. It's a direct response to a very real, growing crisis in how we train these models.
The whole journey has been a series of major shifts. First, it was small, clean, curated data sets, like Wikipedia. Then we moved to web scale, just grabbing everything we could find. After that, the focus shifted to quality, using AI to sift through the internet junk and find the best stuff. And that brings us right to today's frontier, using AI to generate brand new data, which lets us upcycle the mountains of text we already have.
For the longest time, creating training data has felt a lot like alchemy. A mix of gut feelings, guesswork, and maybe a few secret recipes. The goal of this research is to completely change that. It's about creating a system, something repeatable, scientific. In other words, it's about turning that messy alchemy into precise, predictable chemistry.
So how do you actually turn alchemy into chemistry? Well, you run a huge, really carefully controlled experiment, and that's exactly what these researchers did. They broke the whole problem down into 3 key ingredients, or variables, that they could test systematically.
First things first, we need to understand the core technique they used, and it's called rephrasing. The concept is actually pretty simple. You take a document that already exists, you feed it to an AI, and you ask it to rewrite it in a totally new format, maybe as a step-by-step tutorial, or an FAQ, or a neat table. The core information stays the same, but the way it's presented changes completely.
So their entire investigation revolved around 3 big questions. First, the prompts. Which styles of rephrasing actually make the final model better? Second, the models themselves. It doesn't matter if you use a bigger or newer or just a different type of AI to generate the data. And third, the source data. Does the quality of the original document you start with actually matter? Answering these 3 questions is the key to the whole playbook.
And this is where all that hard work really starts to pay off. After running those 90 experiments and sifting through a mountain of data, some really interesting patterns started to show up. Some of them confirmed what they thought, but others were genuinely surprising and totally counterintuitive.
Okay, first up, the prompts. Check out this chart. The bar on the left, that's the baseline, the old way of doing things. The 2 on the right, the table and math prompts, those are their new strategies. And you can see they clearly perform better. This was a huge finding. Prompts that restructure content into these kinds of educational formats, like math problems or tables, were the hands-down winners.
But, and this might be the single most important insight in the whole paper, there's a critical trade-off. While rephrasing made the AI models much better at knowledge-based stuff, it consistently made them worse at common-sense reasoning. It's like the process made them more book-smart but less street-smart. This is so important because it means you can't just blindly chase one metric. You have to balance that factual knowledge with real-world intuition.
All right, get ready for the first big shocker. In AI, we always just assume bigger is better, right? Well, the evidence here says not so fast.
When it comes to generating synthetic data, models in the 1 billion parameter range were perfectly fine. As you can see from the chart, using larger, way more expensive models gave them no real benefit. In fact, performance even dipped a little. This is fantastic news for anyone worried about cost and efficiency.
And now for what might be the biggest surprise of all. It turns out you can't just train a model on 100% synthetic data. It just doesn't work. The real key is to mix the new synthetic data with a high-quality original dataset. And why? Well, remember that trade-off? The original data brings back the common sense reasoning, those street smarts that get lost in the rephrasing process. So the choice of what you mix in ends up being a massive driver of your final performance.
Now, I know what you might be thinking. What about model collapse? That fear that an AI trained on AI-generated data will eventually just go crazy. Well, the researchers address this head-on. That problem only really happens in a closed loop, where a model is only learning from its own output over and over again. But that's not what's happening here. By always mixing synthetic data with original human data, you completely avoid that downward spiral.
So, after all that investigation, all that analysis, what's the final verdict? Well, the team took all of these incredible, sometimes surprising findings, and they boiled them all down into a clear, actionable playbook, a recipe for creating the best synthetic data possible.
So here it is, the secret sauce. First, use those prompts that restructure information in educational ways, like math or table. Second, use a small, efficient model, something around 1 billion parameters. Third, and this is the big one, always mix your synthetic data with an original dataset, especially one that's strong in common sense reasoning, to bring back those street smarts. And finally, remember, this process improves good data. It doesn't magically turn junk into gold.
Okay, so we have the playbook, we have the recipe. But let's zoom out for a second. What does all of this really mean for the future of AI? This research points to a much bigger shift in how we even think about building intelligent systems.
Look, this isn't just about a new dataset. It signals a fundamental change in the entire field. For years, almost all the massive computing power was spent on that final training run of the model. Now we're seeing more and more of that power moving upstream to curating, filtering, and scientifically engineering the perfect data. The focus is shifting from just training the model to designing its diet.
And that leaves us with one last, really fascinating question. For the first time, we have a real playbook to create trillions of high-quality training tokens with scientific precision. We've actually turned alchemy into chemistry. So, what new possibilities does that unlock? What's the next frontier for AI, now that we can truly engineer its intelligence from the ground up?